Alright, so we're jumping back in here, and we have some new wallpaper here. This fine lady is Misa Amane. She's a character from the Death Note anime, and if you're into anime and you have not watched that series, then I highly suggest you do so. Does she have fucking awesome boots over here? She does. You know, obviously there's other parts of her that are awesome. I leave that to you to figure out. Uh, but we're gonna bring up Firefox. I mean, if I start talking about bits and bytes and I leave this kind of picture up there, then obviously no one's gonna be thinking about bits and bytes, and they're gonna be thinking about other things. So do our best to do what we can do in that respect. Go back to Firefox here, articles engineer. Go back to principal locality. I want to say that's where we left off in the previous video. Got some crap here. Got cheat engine open. Alright, so I don't know. New scan. Delete this, sort of reset this a little bit. So what are we going to talk about? We're going to talk about reverse engineering cheat engines so that we can prove our theory of names being equal to addresses. So in the context of the previous video, we were saying how x equals some value. X is a variable name. 1 is a constant value that we can just assign to any variable. And the constant could be anything. We just type in a shitload of numbers right here. What's the computer going to do with that huge string of numbers? That's data type dependent as far as what it's going to do. We talked about that, so it doesn't matter. But we're just going to keep it simple. X equals 1. What's the computer really doing? It's saying that, well, X equals some memory location. That memory location has some value. That value in our case is 1. And that's it. And anytime we refer to the value of X, the computer is sort of going to reverse that process, say Y equals X. And what's it going to do in that sense? Well, okay, so reverse is the wrong word, but it's going to basically go back through this iterative process. So we have a new variable, or a variable. Maybe it exists, maybe it doesn't, who cares? We have a variable Y. We're going to set it to the value of X. What is X? Well, X equals some memory location. The computer is going to dig up that memory location. It's going to go to that memory location, such as it's doing right here in this address list. It's going to find the value in that memory location. In our case, it's 1. It's going to substitute it and just be like, well, Y equals 1. Done deal. Nothing more complicated than that. Delete a couple lines here. Alright, now we're going to take a deep breath. See how we can reverse, or how are we going to broach the topic of reverse engineering cheat engines so that we can prove our theory of names being equal to addresses. Well, let's minimize this, minimize that, minimize this other thing. We're going to stare at some boobs. That's fine. Launch the game. Just going to load the game. Let me think about this real quick. We want a value that we can control. We're not even going to load the game. We're going to go to new game. Launch. Done it a million times. Alright. Yep. It was cheat engine. There it is. So, we have cheat engine. We're going to attach it to this process. Shit. There we go. No. Alright. So we're going to bring Notepad back up. I'll bring this down a little bit. And say, like we were talking. Let's. I want to write this down one more time just so we can refer to it while we're going through this. There's a variable we're going to name X. Has a value 1. What's really going on? X equals a memory location. That memory location has value. And the value of that memory location is 1. So this is sort of the 3-step process of, this is what we write in a programming language. this is the intermediate step that the computer is going to translate the first step to, in order, and it does this for a variety of reasons, which we covered, foremost among them being abstracting away some of the difficulty of dealing with memory locations and dynamic memory and things like that. And the last step is that it's going to retrieve the value, or it's going to assign the value to the memory location, to whatever we say on the right side of this expression. So, again, in the context of the previous videos, it's not rocket science. Let's see what we got left. Alright, we got plenty of time. So, was that 6 minutes? Yeah, we got some time. Alright. How can we use Cheat Engine to prove what we're talking about here? Well, we're going to go back through what we said, 27. Or, not what we said, but through some of the basic steps that we've done in the previous videos. 16. Down to 2 values. We know we're on the right track. Using the previous videos, we know we have it. Those are the 2 values we want, just in case. Change them to 6. Be absolutely sure. Double click. Set this to some value. Set them both to some value. I don't want to deal with any of the discrepancy stuff right now. Yep. Alright, 61. That's the karma that we have for the character creation screen. How is this going to help us? Well, again, let's break this out a little bit. So we'll set up some notepad formatting like we've done before. So what is this first statement that we're talking about? This is what we write in a programming language. Is this what we're actually going to write in a programming language? It varies from language to language. The exact syntax, if you will, is different from language to language. That's all I'm going to say. It's just different from language to language. But for the sort of our purposes here, our general purposes, we're basically sort of making up a language on the fly. Doesn't matter what the rule. I mean, we're setting the rules as we go, and that just makes it easier on us. That way, we don't have to sort of define a huge set of rules from the get-go, and then make sure we operate in those constraints. Instead, what we're doing is just making up constraints as we need to, and that way we can cover as much as possible, or the topics that are relevant, without having to deal with a huge set of extra rules that we're never going to bump into or something like that. So, what are we writing in a programming language? We're writing x equals 1. What is the computer doing behind the scenes, behind the curtain, if you will? Fuck it, curtain. Single or hyphen. What the computer's doing is it's taking the variable name x. It's creating or assigning a new memory location. We'll indent here and say, what is a memory location? We'll go back up one. A memory location is some hex value relative to the process's memory. There's a lot embedded in this statement, but if you've been going through the video series and whatnot, this general statement should make sense to you. So, what's a hex? It's a memory location. Memory location is some hex value relative to the process memory. Here's the process. There's a memory block associated with it. Feed in a memory location, such as this. Takes that memory location, that address, if you will, applies that to the process memory, gets a bit pattern, returns that bit pattern. Cheat Engine interprets it in a specific type way and returns a value according to the type. We're not going to go into crazy detail there. So what do we got here? Alright, 10 minutes. Got a little bit. So now we're going to get down to the third instruction, third iterative process, if you will. So now the memory location equals 1. We'll retype this. What is the computer doing? behind the scenes as far as this instruction. What the computer's doing is it's taking the memory location that was returned from the second step, stuffing a value in there. That's it. So now, anytime a program or a script or whatever refers to the variable name x, this is not a fourth step. So we're gonna put a whole lot of space between this. So just what is the effect of all this high-level nonsense? The effect of all this high-level nonsense is that we can refer to totally random memory addresses with a simple name like X. We don't have to type in B45, yada yada yada. I don't even not even gonna bother counting the digits there. I don't even care. Instead of valid thing, valid hex address. I have no idea. I don't care. To prove the point, though, I mean, fuck it, we'll just do that. It's obviously not valid. Do a little bit of this. Get rid of the S. Change it to E. So yeah, it's valid. So anyway, what are variables doing for us? They're abstracting away, providing an abstraction level so that we don't have to deal directly with addresses. So we're does us a very useful service in that regard. There we go. How we're going to use this in the context of Cheat Engine to sort of reverse engineer it? Well, you go back to Cheat Engine. What are we searching for with Cheat Engine? What have we talked about the entire video series? How much time do I have to bullshit about this? All right. What have we talked about the entire video series? We've talked about finding values. We talked a little bit about types. Kind of going over addresses a little bit. Description is a completely irrelevant field to what we're discussing right now. The active thing here and locking values, that means nothing. So we enter values up here. Cheat Engine scans the memory associated with this process, finds those values. We filter those values down to a level where we can double click or add them to the address list. They come down to the address list. Everything down here in the address list has a memory location associated with it. And so what is Cheat Engine really doing? Well, I'm sorry, let's not do that. Let's get rid of these two bottom steps. What are we writing in a programming language? We're gonna have to stop and jump into this in the next video.